Hello everyone, and welcome to the second episode of our Zetta Platform webinar series. Today I'm here with Gabriele.
Hi.
Gabriele Baldoni is the Zetta Pass architect. And the program for the day is to do a quick recap of what we presented last week, just 7 days ago. Just recalling why we did the platform and what the Zetta Platform provides. And I'll take you through that quick recap. Only to then move to an entire hands-on session in which we will see how to use the Zetta Platform and to do pretty interesting things with it. So let's go and let's get started with our recap. So as you will recall for last week, and if you weren't there and have not had a chance to see the recording, in any case, this is the reason precisely why I'm doing this recap. One of the problems that we wanted to solve at ZettaScale is that of this integration Frankenstein that people are having to deal with when trying to build applications that have to scale from the microcontroller up to the data center. And again, you have to hook up together multiple technology only to have data flow from a microcontroller up to the data center. Well, I should say you had to, no more with Zenoh, right? And again, when dealing with data at rest and then computation, you had to integrate multiple technologies. It was, again, an integration nightmare, very cumbersome, very complicated, and in general, very hard to have decent semantics. So we built the Zenoh protocol to address ground up this problem. Most of the protocols that were around when we started working on the Zenoh protocol and started conceptualizing the Zenoh protocol had been around for at best 20 years, if not 30 or even more. And in 20 years, the world has changed a lot. As a consequence, some of the protocols were working very well on fixed network. Other protocols, let's say like COPE, were working very well on a constrained environment. Other protocols, were working like MQTT well on the internet, but just imposing over you a hub and spoke architecture. But there was nothing that as a single protocol could work efficiently from the microcontroller up to the data center. That was a big problem. Scale out. So provide you with something that can really support internet scale application, but also scale down, which is being able to be deployed on a constrained microcontroller, as well as scale up, which is perform when you are on high-end networks and high-end hardware. Now, we took the challenge. Zenoh was the result of taking up the challenge. And besides addressing the problem of having a unified protocol to communicate from the microcontroller up to the cloud, we also address the problem of data at rest, allowing you and providing you with a framework that makes it possible to have storages where it makes sense for your application, so decentralized. And as a side effect, we also managed to, within the same framework, provide abstraction to represent distributed computation. As you probably know, Zenoh runs everywhere, so you can run on top of a data link, a network, or a transport. As such, it's available for serial, OpenThreadX. We're about to release a version for LoRa, but it runs on TCP, UDP, QUIC, you name it. It is available in your favorite programming languages. It is implemented in Rust for security, safety, and performance, and it has only 5 bytes overhead. Supports any topology, right? So you can do peer-to-peer under a full connectivity assumption, so what we call a click, but we can do peer-to-peer over an arbitrary mesh, and peers can also mediate communication for client. This is very, very useful in some robotics application where you have formations with some constrained robot that cannot afford to communicate peer-to-peer. And then we have infrastructural nodes, our routers. These routers are the elements that we help to provision with the platform, along with the plugins, as we described last week, that you can have in these routers. Again, Zenoh runs on your favorite microcontroller, can run on Arduino, Mbed, Zephyr, you name it. It's very easy to port on your environment. And Zenoh Pico will be available. MISRA is already MISRA compliant and will be available as ASIL-D certified software Q1 2024. Great performance, as I showed last week. So if you want more details, please go back and look the episode from last week. And extensibility. Again, we don't live, there was this famous quote that was, repeated in a movie that came out early 2000 about a boy, right? In which Hugh Grant used to say, no man is an island. Well, we could say the same about protocol. No protocol is an island, right? What does that mean? Well, it means that inevitably, right, you are not isolated, you don't live in isolation. And although some systems are able to use Zenoh everywhere, This is only true for new system development. But most of the time, you already have deployed system, you already have deployed framework that are using perhaps DDS, MQTT, perhaps Scope, or maybe OPC UA. And so it is essential for a new technology to have easy connectivity. And Zenoh was designed to make sure that you can easily develop plugin to third-party protocols. So we already integrate, as you will see in the demonstration, with DDS, with MQTT, and so on and so forth, as well as our geo-distributed storages can rely on any third-party storage technology. Your favorite could be InfluxDB if you need time series, RocksDB if you need a key value stores, or perhaps a traditional relational database, or why not Amazon and S3 or Minix. So, real beef, why Zetta? Well, Zetta is a PaaS that provides you with a turnkey solution, as Gabriele will be showing shortly, that makes it trivial for you to provision an infrastructure that goes from the data center down to the device. And as we will see shortly, this is what we will be doing now. From a data center down to the device. Okay, that's pretty cool. And our user, as of today, had mostly to deploy managed infrastructure by themselves, which is usually not your core business. It's complicated, right? You have to deal potentially with cloud independence, if that's important for you. You have to deal with high availability. I mean, there are lots of concerns that usually are not part of your core business. You just need to solve a communication problem, and perhaps you need an infrastructure, and managing that infrastructure, I mean, it's just something else that really would be better if somebody else did it. And that's why we did, among other reasons, the Zetta platform. So Zetta leverages Zenoh, again, to unify communication storage and computation from the data center down to the tiniest microcontroller. As we saw, thanks to Zenoh integration, provides you with connectivity with any other protocol. And if it's in there, you can develop in 1 or 2 weeks. And it is extremely space and time efficient, as we've discussed. It is cloud independent. So you can decide which cloud you want to use to deploy your infrastructure, and even to use multiple cloud providers. And by the way, you can integrate your on-premise infrastructure, and as we will demonstrate, as Gabriele will demonstrate, go down and even deploy down to a device, and then manage, monitor this infrastructure from a centralized place. Again, here you have a representation. It is cloud to microcontroller, so you can provision end-to-end. And again, our Zetta platform is composed by a PaaS. As a structural element, you have the Zenoh routers, you have all the connectors that you can provision on the infrastructure, a set of tools for monitoring, and API in your favorite programming language. The other nice things is that, as I explained last week, even if part of your system are using DDS or MQTT or some other protocol that we integrate with, you can write new portion of your system using Zenoh or Zenoh API, because perhaps they are simpler, more expressive, and it will interoperate. As we do in robotics, sometimes we have robots that are using ROS. Inside the robot, they're using DDS, but these robots are communicating between each other using Zenoh, don't even know, okay? But yet they get all the benefits in terms of scalability and the ability of working efficiently on wireless networks. So again, plenty of connectors and more can be easily added. But no, sufficient talking. Let's see the Zetta platform in action. So Gabriele, the floor is yours.
Yeah, so thank you, Angelo. So while I go online to show your, what is the demo about? Okay. I'm not able to see my screen, which should allow it. Okay. Now my screen should come up. And
yes.
Actually, okay, good. So what we're going to see, as Angelo said, we are going to see a deployment that is from the device, from the cloud to the device, to the device again. So what we are going to deploy actually is some router in the clouds that will be our, let's say, entry point for our infrastructure, so our actual managed infrastructure that will be on the cloud. Then we are also going to provision inside a robot a Zenoh router with a plugin for DDS that we are using to bridge communication between ROS and Zenoh. And then we are going to connect to this robot with peer-to-peer a microcontroller that is this very small ESP32, which is going to run Zenoh Pico, and this will connect directly to the robot. And then we will connect our monitoring to the cloud. In this case, our monitoring will be showing the results of the LiDAR processing of the robots, and means that we will be able to control our robot directly from the cloud, just seeing the data from the LiDAR. But that's enough talking, so let's go for real. So I connected to my Zetta Platform dashboard. As you see, I have already one project running, but let's create it on our one for this demo. So let's call it Robotic Demo. So I need to set a name for my project. If I want, I can set any description, describe it to help me understand what is the project about. So about driving a robot. And if I want, I can select in which provider I want to deploy. In this case, we have just Linode configured, so we are going to deploy inside Linode. And if we want, we can also select a domain name. Then we have our first Zenoh router. We need to configure it. In this case, this Zenoh router is on the cloud. So which means that if you would like to add a connector, we could add an MQTT connector because it makes sense to have it on the cloud, while, for instance, a DDS plugin makes little sense to have it on the cloud as is based on multicast communication. Let's say you want to add an MQTT plugin, but if I want, I can also add storages. And storages are used to store data in Zenoh. So I can give a name to my storage. Let's call it store my data. I can give a key expression that I want to use to store. So in this case, let's just use robot one / star. So which means it will store everything that matches this key expression. And then I can select which kind of storage I want. If I want to store only the last value, or if I want a time series storage. In this case, let's put last value. Then I click next. When I click next, I can still check if everything is okay, or let's say I don't need any more of this MQTT plugin, so I may need to remove it. And then when I'm done, I can just ask to create this project. And I see that the project is deploying. But without further ado, let's go through a project that we already have running. So we can click on the name of the project. We can look at this network map. In this case, we have one single router on the cloud, which is our infrastructure. Then I would like to connect something to this infrastructure. So let's say, as said in the slides, I want to have something running on my robot. So what I will do, I will go into use my project. I will check for Onpremise Node. And then again, in the similar wizard to the one that we did for creating a router on the cloud. But in this case, the router will be for on-premises. So again, what I can do, I can add storages and connector. In this case, this router has to run in a robot, which means I need to have DDS communication. So I go to the connector, I select as connector type DDS, and I will add a scope. In this case, I have this single robot, so I will put it robot 1 as a scope, which means that all the topics that are going to be sent through DDS are going to be prepended with this robot 1 string that then will be used to route data in Zenoh. I can configure everything that I need for my configuration, so like the allow list, and we have also tooltips explain to you what the actual configuration is. And domain names, group activity, all the configuration that you usually have in the DDS plugin, they're also available on the pass.
Yeah. And by the way, maybe we should mention that although here we are showing this as a plugin, some user might have used it as the DDS bridge, yes, in ROS2. Exactly.
So in the case of the pass, they come together with a plugin. Why so? Because you may want to add also storages directly. So why to add another op? In that case, you can have your router with your DDS plugin and your InfluxDB. So let's imagine you want to store movement of your robot directly in your robot to retrieve them later to do some record and replay, or you want to store it also on the robot for some reason. In this case, you just need to deploy a single binary with a set of plugins. In this case, the Zenoh router is the binary, the DDS or the InfluxDB plugin can be the binary.
And so if you've used the bridge, all the configurations that are on the bridge are exposed as part of the configuration in the plugin, and so allow list, all those sort of things.
They are exactly the same. Of course, for a different plugin, the configuration is different. Like for MQTT, as you have seen, there is a slightly different configuration, but the configuration, of course, depends on the plugin. But everything that you can configure, like that up to nowadays, you configure manually in a JSON file, from the past, you can just configure it through a web interface. Say I'm done, I want just this plugin, and then what I can do, I can create my router on premises. So it will take few seconds to create the configuration that then I can download. So while it's creating it, let's connect directly to my robot. In this case, in my robot, I have already downloaded a configuration. And what I will do, so here we can check, so if it actually works, I click, it will download to me a target Z file in which I have both a Docker compose file, which is used to then spawn the router, and the configuration of the router. But let's go back to our robot. So I'm connected already to our robot, and I have already let's look. I have 2 files, the Docker compose, as say, and the configuration of JSON. And then what I can do, I can just spawn the router with a simple command. I just do Docker compose up, and this will start a router inside my robot.
How about security, Gabriele?
So everything that is connected to the pass is configured to have TLS for this version of the pass. For the next version of the pass, so the one that will be available commercially, the communication, the security can be decided by the user. So either be mutual TLS authentication based on certificate, or TLS authentication plus username and passwords. Of course, why we decide to go straight with only TNS on the cloud? Because of security reason. We cannot just leave open a TCP connectivity to everyone. So that's why we configure the connectivity on the cloud to be only TLS. Yeah. And actually, we can see that if we click on the client and on the JSON configuration, we can get how to connect to this particular Zenoh router, and we can see that it says that is TLS. And of course, the domain name in this case was generated by us in a unique manner, so it's sure that there will be no conflict on the names. So we deployed our router. Let's see if it's actually there. Yep, it's there. So you see now I have 2 routers. One is running on premises, and one actually on the robot, and the other one is running on the cloud. Okay, fine. But now I want to connect something to this robot. So as said, I want to connect my
and perhaps something else that is interesting to understand. You understand that this robot is running inside our company network.
Yes.
Right? There are 2 firewalls, right? There is nothing that gets in. And it's secure communication between the Zenoh router on the robot and the Zenoh router on the cloud. We didn't have to configure anything in our network. We didn't have to configure anything to set up security between the router.
It's directly in the package you download. And
exactly.
Actually, you can see from the dashboard that, see, this link is dotted like blue, cyan, blue line, means that the link is a TLS link. In this case, this device, the one that I showed before, is a Zenoh Pico device that is connecting in TCP towards the router on premises, so the one on the router, and the link is yellow. Yellow indicates that this is a TCP link. Yeah. So this link actually is not secure, but all the information that is going out, to the cloud, actually then is being secured by this TLS link. Okay, so we have our robot connected, we have our controller connected. What about now connecting an application to show the data actually going through the cloud?
Yes. And as you do that, something else that is worth remarking is that one of the advantages of Zenoh, right, is that you can communicate peer-to-peer if you happen to be on the same network, which is what is going to happen between the little controller and the robot, but still information is available anywhere as far as you have Zenoh connectivity. So as Gabriele will be showing in a moment.
So as we can see, I have another thing connected to the cloud, which is my dashboard for the LiDAR, which is this little icon here. As we can see, is again connected through TLS because it's directly connected to the cloud. And then means this guy is subscribing. So this application is subscribing to data being produced by the robot, which means that if this application was not there, no data was being routed, because that's the beauty of Zenoh. If there is no one interested in the data, why bother sending it? And also means that I'm able to control the robot directly from the cloud if I want, because I can just push some messages through the cloud to the robot, or the other way around, I can see where my robot is going while it's automatically driving.
Yeah.
So,
and by the way, we've been talking about the robot. Shouldn't we show the robot?
Yes,
so hold on a second. Let me move around the camera. So I'll disappear for a moment. So turn this one around so I can see.
And meanwhile, I'm going to drive the robot.
This is the little, well, not so little, but this is the robot. And this is a ROS, hold on, let me move this around. Yes. This is the ROS2 based robot.
It's called the Usarion, yes, quite.
So there is Cyclone as the default DDS implementation in this robot, but then all the communication between the robot and everything else obviously is Zenoh. And
so as you can see, while I'm driving, while I'm driving the robot,
I'll try to show the two. If you bring it closer to you, yes. Maybe I'll move it. I'll move it here. Let's see.
You can get it from yes.
Yeah, because this way I can try to. Yeah.
So as I'm tilting the controller, you see that the robot moves, but also the information from the LiDAR is being updated almost real time. Well, actually real time, which means I'm able to drive, avoiding like the foot from Angelo in this case, or if I want, I can try to drive between the two poofs. bit tricky to drive with this kind of controller, but still, I'm able to drive it and I can see the information from the LiDAR being up to date.
Yeah, and again, communication between the microcontroller on the this
happening
microcontroller. There is Zenoh Pico,
Yes.
so still Zenoh.
The robot still Zenoh, as we can also tell from the stickers.
And so maybe we should spend a little bit, few words on the configuration that we're using, because this is very often used in robotics, right?
Yes. So what we are actually doing, all the DDS traffic is not leaving the robot, and the Zenoh router on the robot is configured to get multicast DDS information only from the localhost interface. Why this kind of configuration? Because this configuration allows people to avoid multicast storm in a noisy environment, like could be a Wi-Fi environment of a factory, which if you try to use plain DDS with, let's say, 1-2 robots, it might work. But if you think a warehouse with hundreds of robots is not going to work easily. So what we do in that case, so what we propose to the user actually is you configure your robot to do DDS communication only on localhost, which is very efficient and makes a lot of sense.
And it's a new default for ROS.
Yes, and now it's the new default for ROS. But then you say, yes, but in that case, my robot cannot communicate with the external world. And that's where you can use Zenoh. That's where Zenoh takes its play. You put a Zenoh router or a Zenoh DDS bridge with the Zenoh DDS bridge plugin, for repetition. And then all of a sudden, your robots are able to communicate between themselves without needing multicast storm of data, or if you want, you can use whatever topology you want. So either peer-to-peer for your robots, so that when they are close to each other, they connect, or they are all connected to some cloud, some fleet management on the cloud. That's really depends on your use case. But this allows you to avoid the multicast traffic on the Wi-Fi. That means it will also work over 5G network, because on 5G network, there is no easy configuration for multicast over the radio link. And this means that you can control all the data that is also going out of the robot. Because if there is no one interested on the data being published by the robot, the data is not going to leave the robot, which means that you are saving also bandwidth in that case.
And there is another reason. So maybe the people that have not used the Zenoh plugin yet didn't fully get the importance of the prefix. Can you go back to the prefix?
Yes.
So if you take,
I can get it from the configuration.
Yeah. So suppose you get you have 2 robots and they're running on the same network, 2 base robot. For instance, 2 Turtlebot, just to give another example. If you want to use to do telemetry on them, they will end up using the same DDS topics, and you have no way of distinguishing automatically between one or the other unless you use different domain. But then if you use different DDS domain, then it gets quite complicated. And so the ability that we provide in the Zenoh bridge or the DDS plugin for Zenoh to have a prefix for the robot, that prefix becomes part of the Zenoh key. And so you can use it like any other element of a Zenoh key, right? If I want to get something, suppose I want to query some information from all the robot, then I would use a */something, right? And if I want to interpret a specific robot, then I would use robot1, whatever. In this case, the topic is usually the teleop or country code.
Which is RT/CMD. Yeah. So actually in Zenoh, the data will be named robot1/RT/CMDVal, which, as Andrew said, means if I want to control more robot, I will just put */RT/CMDVal, and I can easily control more robot, just sending one message. Yeah,
and the other important thing is, if we remain on the configuration, obviously we weren't necessarily using it now, but this was quite instrumental. For instance, in the India Autonomous Challenge, where cars that are using ROS2, right, for being driven, they are communicating over a Cisco card, which is a wireless network with quite a few limitations because of the speed, because of the noise environment, and so on and so forth. And there are limitations in terms of the maximum size and the maximum frequency with which you can send data. So if you can, one of the problems that usually you get is that when you design a robot, you consider about the sampling frequency that is required, to maintain a given feature of your robot controllable. And again, there is control theory, decides, and Shannon theory decides what is that frequency. But then, if you need just to observe as opposed to control, perhaps you don't need to observe at the same frequency. And so the same information might need to be shared at a different frequency. And this is precisely what you have here in row 43, if my eyes don't betray me.
Max frequencies.
Yeah, max frequencies control precisely the maximum frequency at which data will leave the robot. So Zenoh will be doing downsampling and a few other things, as Gabriele was mentioned before, like controlling exactly what you're exposing to avoid overwhelming the network. If you put all of this together, plus the fact that Zenoh is an incredible efficient protocol, this is why usually those R2X applications tend to use Zenoh. And this deployment scenario, it's quite common, right? And you saw how simple it was to set up. Now, suppose that instead of wanting to deploy the router on the robot, I had some edge server.
It was exactly the same thing. You just download it from the pass, copy it on your server, and on your server, decompress it, Docker compose up, and you have your router running. You want another router, you just go again through the configuration, download another file. I don't know, maybe you said, let's say you have your system with already a lot of MQTT device connected, and you want to use now Zenoh. What you will do, you will just download most probably a Zenoh router that, let's say, you want to avoid MQTT traffic to go to the cloud. So download your Zenoh configured Zenoh router with an MQTT plugin, decompress it, run it, and all of a sudden, all your devices that are talking MQTT can connect to this router and then talk to Zenoh to connect to the cloud.
So let's go back to the diagram, because there is some other interesting insight that, Gabriele said it, but I just want to underline.
This one or the other one?
No, this one works very well. So you see that the microcontroller is communicating peer-to-peer with the robot, right? By the way, this microcontroller, if the robot was, in let's say our Dutch office or our UK office, would have used perhaps would have communicated across the internet. But as the two are in the same network, they can communicate peer-to-peer. That's because they're using Zenoh. Suppose you were doing the same application using MQTT. Even if the controller and the robot were in the same room connected to the same network, you would have traffic going to the cloud. And that's not good for several reasons. It's not good for latency, right? Because I'm there. It's not good because in some application, I need to control the robot even if my internet connection isn't there. It's not good for energy because, by the way, we shouldn't forget, and we are telecommunication engineers, so we know that well, right? That communication is what consumes the most energy. And it's not just the battery that, of this robot. It is all the energy that you're going to use in the routers, right, that are deployed on the internet and on the infrastructure that connects us to perhaps our office in UK or something on the other side of the globe, right? So that's quite important.
Smart meter at home, just to let you save a few cents, maybe it's consuming way more energy just to send this data to the cloud. All the internet.
And then we talk about green, right?
Exactly.
We really have to think and look at the entire system. And then the last point is OpEx, okay? You have now a pass deployed on your favorite cloud provider. They are great, very competitive, but each time you send data there, you pay. And most of the time you're sending data that shouldn't get there. This helps you keeping that data locally. And as a consequence, reduce your OpEx. And we use our platform, so you have, in spite of the amount of communication that is in your system, right? If you have the ability and it makes sense to maintain that communication local, all of a sudden, your price, right, goes much down because you don't have any more that OpEx with the inbound and outbound data. Because recall, if that was deployed on a cloud, I have the inbound data and the same data that I wanted to give to Gabriele, right, is coming back to him. It's like, why are we doing that? Okay, so maybe what we should do, Gabriele, because you showed the documentation the configuration for connecting a Zenoh application. Maybe we could go through it, show how actually they do it.
What we can show actually is the configuration I'm using for this particular application, which is the one that I just downloaded from the cloud. So let me just go to that directory. Goes to Zenoh. Python. So what is the LiDAR? Yes.
Yeah, we can even show.
Yes, we can also show. So that's why I'm opening. Okay. So VS Code decided to open the wrong file. Yes, it's perfect. Okay, it's opening there. Let's make it bigger. So this is exactly the same configuration that I just got from the cloud. So if we compare this to the one provided by the PaaS web interface, it is exactly the same. In this case, I decide to connect it as a client, but if I want, I can collect it also as a peer. Yeah. And this is the base configuration that I need. At the end, I need the connect and the endpoint, which, as again, is a TLS endpoint because we are doing TLS for connection to the cloud with the domain name that was the one generated automatically by the pass.
So who is generating the certificate for these domain names?
So for this domain name, we are generating the certificates. In particular, in this case, we are using Let's Encrypt to generate the certificate. So we take care of all the handshake and verification of the certificate generation. That's why when you deploy something for the first time, it will take a bit more time because, of course, we need to go through the DNS propagation to verify that the certificates are generated. In the case of mutual authentication, the situation will be a bit different because in that case, we may ask the user is PKI because most of the time the user already have a PKI that they want to connect and they want to be sure that the device they are connecting to Zenoh are exactly the device they are making. So for example, imagine this is the device manufacturer in production. It will come tempered with a TLS key that maybe we as a Zenoh router, we just need to verify that it's this guy. And in that case, we will need to connect to the PKI infrastructure of the user. Or we can try to generate it our own in the case the user doesn't have any PKI infrastructure.
Yeah.
And actually, if you want to see the application, right, from an application point of view, accept all the types, argument parsing, and so on. From the Zenoh point of view, it's quite easy. So we are reading, in this case, a configuration file directly. We are creating a configuration file. Then again, configuration to do the plot, doing the plotting. And from the Zenoh point of view, it's just opening the session, declare a subscriber.
And that's it.
So the only Zenoh line here are actually 1 and 2. All the rest is just application logic.
Yeah.
So you can see how easily it is to just get this information from connecting and using this information to actually plot useful information for you. And yeah.
Great.
So what else we can show?
Well, I think we can see.
We can actually we can tear down and show.
There are some questions. If you have any question, please just don't hesitate to ask them on the chat because we'll answer as they come.
Just to show that the graph is actually being updated. I kill something and it just disappears.
Yeah, and again, so maybe we can go back to how we are staging this, right? So obviously we announced our Zetta platform on the 21st of June, and the platform is now available for evaluation. But you need to apply because we have limited number of evaluation that we are making available. And that comes with a commitment on your side, which is providing feedback. Why? Because not because we are just egoists, right? But we want to improve our platform. So we already had some good feedback that we are internalizing for our next iteration. And the general availability in terms of commercial product will be in second half of September. Along with the general availability will be some command line tool.
Yes, that will be used at the end. We'll reproduce the same functionality as the web interface, but let's imagine you want to automatize things. In command line tool, it's easier to automatize.
And even some of the downloading of the image, the starting of the image, you will be able to do with a command on our command line, like you used to do on some other PaaS platform. That's really it. Okay, so there is a question whether we can run the PaaS infrastructure locally. So we are independent for the cloud, and the way in which we are building our PaaS is in such a way that eventually for customers that are interested in running completely on-prem, that will indeed be possible, okay? Then something else that we have not shown here, and perhaps you had seen in some of our offline tools, is that we were able to show quite a few metrics. So that's coming up with the release, as well as integration of tools for key plugins like DDS, right? So right now we have a DDS system as per the robot. Suppose, right, that the robot was sitting again on the East Coast. There was a problem, and I need to understand what's happening, right? Through the PaaS, I would be able to click on the router where there is running on the robot or on the subsystem where the robot is connected, load the DDS plugin, and inspect all the DDS related information that typically you would want to see as a DDS engineer or a DDS developer. And we will start obviously with information on the infrastructure for Zenoh, information on DDS, and then we will keep adding monitoring facility for all the plugins. But this will be a central place for visualizing everything. We have demonstrated in the past record and replay. So you understand that this will make it trivial for you to record data anywhere. It makes sense because you could start a storage, again, on your robot, on your edge infrastructure, on the cloud, and then perform query to consume the data at your pace, or create or use the data to do replay quite easily, as we've demonstrated quite a few times in just Zenoh demos. So just to go back to something I was showing, I mean, all the power that you have in Zenoh, right, and the power of the technology with which we have connectivity like DDS and so forth, is just being, I would say, industrialized and completely at your fingertip or at the tip of your trackpad or mouse by means of this platform. Anything else you would like to add, Gabriele?
No, I think that's, as you say, it's pretty much it. Don't know if there are other questions.
So there is a question with respect to programming languages. So you can use your favorite programming language to write Zenoh application. Again, this is just dealing with the infrastructure, right? If before you were using any of our Zenoh infrastructure in your application or not, I mean, nothing changes. This is just being provisioned, managed automatically for you, and all the security is being set up, as Gabriele was mentioning before, by us automatically. So I guess that's it.
Yeah, that's it.
So thank you for being with us today. And once again, if you want to go through an evaluation, we have still a few available, just reach out. Maybe we will provide the email on the, thank you, Daniela. So it's contact@ZettaScale.tech. There are still few slots available. And again, the commitment is that you then provide us feedback, because we want to have this evaluation period to really try to further improve our offering, and arrive in September, with the best pass that can support you from the data center down to the microcontroller, as we have just shown. Thank you. And I'll see you next week when we will be hosting a webinar in collaboration with TT Tech, discussing a little bit about the automotive verticalization of our Zetta offering called Zetta Auto. Take care. Ciao. Bye-bye.